This video is going to be pretty short. We're just going to be talking about electric field lines. So in the last video, we talked about electric field vectors, and those were just little arrows that we drew everywhere. Here, we're going to do a representation of those little arrows. Now our E-field lines are continuous, meaning that they don't stop anywhere. But because we do not have the ability to draw off a page, we are going to stop them eventually. Now the E-field vectors are tangent to the E-field lines, meaning when we draw an E-field line, the tangent to that line has to be equal to the E-field vector. You'll see that pretty soon. Now when the charge is positive, the E-field lines move away from the charge, and when the charge is negative, they move towards the charge. So here we have a positive charge, and we have our E-field vectors, which could just be these little black arrows here. And then we have our E-field lines, which go right through them. Because if we were to draw our E-field lines, we have a line here, the tangent to that line is our E-field vector. So the tangent of a straight line is just the straight line itself. That's pretty simple. Here we have a negative charge, the exact same thing, but instead of going away from it, the lines are pointing towards it. Now here's a kind of badly drawn example, but we have a positive charge on the left-hand side. And if we were to just draw it like we did last time, we have our E-field vectors that point away from it like this. But now what happens when we have a positive charge next to a negative charge? Well, they are going to influence each other because the positive is going to be attracted to the negative. So instead of having its lines just going away, it's going to be pointing towards the negative. They are being attracted to one another. But remember, our positive vectors are pointing away from our charge. Our negative ones are pointing towards it. If I were to draw my E-field lines, I would be drawing lines and their tangent is my E-field vectors. So right here we see a straight line from positive to negative. The tangent of a straight line is just that straight line, so that's pretty simple. So we just draw a straight line from positive to negative, and we know that our E-field vectors are straight along that line. Now what about here? See how it kind of like curves this way? Well, if we were to draw that curve, at any single point, the tangent of that line is going to be our E-field vectors. So let's say this point that I'm pointing at right now. If I were to draw the tangent to that, I'd have an arrow pointing this way, which makes sense because that would be what it would look like if it was just a vector. So this is just giving us a better visualization of what is actually happening. And when we're drawing our E-field lines, we're not going to be drawing all of these arrows like I did. I just did this so that you can maybe understand more what's happening. So if this doesn't make too much sense, I want you to try drawing some out by yourself, drawing all of your E-field vectors first, and trying to connect them in a way that the tangent of your E-field lines are equal to your E-field vectors. Now here's some better visualization. In this one we have our negative charge, and this time we have our negative charge as well. These two negative charges are going to be repelling each other, meaning that there's not going to be any field happening down here, not much at all. And we also know that when we have a negative charge, we have our E-field lines that are pointing towards it. But see here how they're all curved? It's because they're being repelled by these negative charges. So again, draw your vectors first, then draw your lines. Now we have a positive and a negative, just like we had them last time. And they are being attracted towards each other. So the positive is being attracted towards the negative. Again, something like this hopefully will come more naturally the more you practice it, the more you see it. But that was just a little bit of an introduction. Our next video is going to be about uniform fields.